dear students, this is the very important concept in this video. I am telling you the details about the analytic function. So you can write analytic function. So what do we mean by the analytic function? First of all, this is very important. So what do we mean by the analytic function, my dear students? Is nothing but if I am having the function fz is equal to u plus iv, or you can say fz is equal to u, this is nothing but function of x and y, plus iv, this is also the nothing but function of x and y. This is equation number 1. If I am saying equation number 1, this is the complex function fz, and yes, it is the analytic function. If I am saying the complex function is nothing but it is the analytic function. So if it is the analytic function, then it should be the differentiable. Let I am saying it is analytic at point z is equal to a. Let us suppose I am having the point, if I am having the point at z is equal to a, it is differentiable, then we can say it is the analytic function. Fine. You can write if the function fz, which is given by u plus iv, if it is the analytic function, then it is the differentiable at point z is equal to a, then we can say at point z is equal to a, the function is analytic function. Also write down second point also, if z is equal to a, at z is equal to a, if the function is not analytic, then fz must be the singular function. That means if it is not differentiable, then it is referred as a singular function, then this a is nothing but the singularity. This a is nothing but what? Singularity. For example, if I am having fz is nothing but log z. So log z, I am having the differentiation f dash z is nothing but 1 upon z, but yes, at z is equal to 0, right? It is what? Infinity. So it is not defined at z is equal to 0. So I am having at z is equal to 0, or you can say at point 0, 0, the function is not analytic. Fine. The function is not analytic in the sense what? Here at z is equal to 0, we are having what? Singularity. Fine. We are having what? Singularity. Okay. Now, so this is nothing but the analytic or like. So if I am having what? The condition to be the analytic function, that we will have definitely, but here if I am saying about the entire function, which is basically asked in our GATE 2019, the entire function. If the fz is a function and it is if fz is analytic, right? If fz is analytic in entire z plane, on entire z plane, I am having the complete z plane or z domain, we can say. If it is the analytic in complete z domain, then it is referred as what? Entire function. Fine. This is referred as what? Entire function, my dear students. Entire function. What is the basic condition of analytic function? The condition of analytic function is nothing but Cauchy or Cauchy's Riemann equation. So what is Cauchy's Riemann equations? So here I am writing the Cauchy's Riemann equations for the analytic function. See, we can have some more examples of the analytic function and not analytic function, singularities also, poles and zeros. We have plenty of things, but yes, in singularities we have some kind of singularities like essential singularity, right? We have the what we can say removable singularity, essential singularities, zeros. So we'll deal with that also, but yes, they are the less important things. The very important thing is nothing but CR equation here. So I am writing here CR equation. So CR equations are basically two equations, my dear students. If I am having u is equal to okay, not I am having u exactly, I am having u plus iv. If the function is nothing but u plus iv, fine, and u is the real part and v is the imaginary part. And if it is analytic, I am saying if the function this is analytic. If it is analytic, then the what is the CR equation? The CR, it satisfies the CR equation. It is nothing but del u by del x. This is equal to del v by del y. So this is what our Cauchy-Riemann equation, but yes, this is the only one equation. I am saying here and, not or, right? I am saying here and del u by del y is equal to minus sign of del v by del x. So this is what I am having here, the Cauchy-Riemann equation, my dear students, in the complex variables for the analytic condition, right? If the function fz is equal to u plus iv is analytic, it should satisfy the Cauchy-Riemann equation, that is del u by del x is equal to del v by del y, and del u by del y is equal to minus sign of del v by del x. Let us have the CR equation in polar form also. So let us have the CR equation in polar form. So I am writing here in polar form. So this is what we are having in the Cartesian form. So the CR equation in polar form. So I have written the polar form equation. The Cauchy-Riemann equation in the polar form is nothing but del u by del r is equal to 1 upon r del v by del theta, and del u by del theta is nothing but minus r del v by del r. So in our GATE examination, the Cartesian form is most probably used. Yes, most used form is the Cartesian form, but yes, we should know the basic, we should know the polar form also. So that is why I am having written in the polar, I have written in the polar form also, but yes, you can see in this form we have ticked it out. So this is the important, right? So the polar form is not very much important, but yes, you can have the basic idea related with the polar form, that's enough, fine. So we will use the Cartesian form here. So Cartesian form is nothing but del u by del x is equal to del v by del y, and del u by del y is equal to minus sign of del v by del x, right? So if let us have here you can see the entire function. I have written what the function fz, if it is analytic in all z domain. So we have some example of the analytic function for all z domain is nothing but e power z. You can see sine z, cos z, also the z power n, so etc. So this all are the examples of the entire function, fine. Let us have some more. So in the addition to have some more, I am having the analytic function, then entire function, and also it is important to form the entire function, right? So I am writing here formation of analytic function. Formation of analytic function. So what is the formation of analytic function? Here to check the analytic function, you can check the CR equations, fine. To check the analytic function, you can check the CR equations, and to form the analytic function, we'll use the Milne-Thomson method. So I'm writing here Milne-Thomson method. I'm writing here Milne-Thomson method. What is the Milne-Thomson method? It is nothing to check, no. It is nothing to form the analytic function. So let us have, I am having with some what you can say some approximation also. So let us have the fz is nothing but the analytic function. It is nothing but u plus iv. Fine. Let us have fz is an analytic function, and if it is an analytic function, it should satisfy CR equation, right? So it should satisfy CR equation. So what is the CR equation? CR equation is nothing but I am writing here the CR equation, fine. So del u by del x is equal to del v by del y, and del u by del y is nothing but minus sign of del v by del x. So this is nothing but the CR equation. Now let us have the fz is equal to, fz is nothing but u plus iv is a analytic function, and if it is an analytic function, dear students, it should satisfy this. So how to form the analytic function? So there are two types of question in the GATE examination. Number one, if real part is given, find the imaginary part. It is the first variety for the GATE, is the first variety of question for the GATE examination. If real part is given, find the imaginary part. If imaginary part is given, find the real part. So please note it down. For this you can apply CR equation, that's it. Mind it and please note it also. Number one variety of question is what? If real part is given, to find the to find the imaginary part, you should directly apply the CR equation, and that's it. You can solve the question by the CR equation. By applying this 2 CR equation, you can solve the question. But if it is asked to form the analytic function by given the value of, or by giving the value of the real or imaginary part, we should apply the Milne-Thomson method. So let us have the Milne-Thomson method for given real value. So I am having, let us suppose I am given with the real value, so u is nothing but given. Fine, this is what real part. So let us have real part is given. So if real part is given, my dear students, if real part is given, then how to form the function fz, that is u plus iv. Fine. So if real part is given, you can calculate del u by del x, and also you can calculate del u by del y. Fine, because there is no v. So this is what, this is our calculation. This is our calculation. I am giving you the steps how to apply. So from equation number 1, if I am having the analytic function, let us suppose I am having the analytic function fz is equal to u plus iv. I am having the analytic function fz is equal to u plus iv. Differentiation with respect to x, I am having f dash z is nothing but del u by del x plus I del v by del x. So this is our equation number 2, and yes, we can put the value of del u by del x. Then what is the value of del v by del x? This is our question mark, right? We do not know the value of del v by del x, but yes, we can have the value of del v by del x here. We can have the value of del v by del x with the help of del u by del y. So we can write from CR equation, I am writing with the help of CR equation, I can say del v by del x is nothing but minus sign of del u by del y. Fine. Then what I am getting is, it is nothing but f dash z is equal to del u by del x minus I and del u by del y, because del v by del x is nothing but minus sign of del u by del y. So this is what we are having, f dash z. And yes, dear students, if I am having del u by del x, can we calculate del u by del x with the given value of real part? Yes, because this del u by del x and del u by del y can be calculated by us, because u is given. If u is given, you can differentiate with respect to x, then we are having the value of del u by del x, and yes, after differentiation with respect to y, we can have the value of del u by del y. So here del u by del x and del u by del y both are calculated by us. Now here some approximation, because we need to find the value of fz, so we need to integrate it. So by putting all x is equal to z and putting y is equal to 0, we will have our answer. So here integrate, so I can write by putting, right, put this value x is equal to z and y is equal to 0 and integrate, and after the integration of fz, here you are having only the value of z, and x is equal to z I am putting, and y is equal to 0. So all the functions is in the variable, is in the form of the variable z, and after integrating this fz, after integrating this f dash z, we are having what, fz, and this is nothing but u plus iv, and this is our answer. So what is the procedure? First, to differentiate with respect to x, then you can have the del u by del x and del v by del x. By changing the del v by del x, you can change here, the del v by del x can be changed with the help of the CR equation. The del v by del x is nothing but del u by del y. Now at last, put x is equal to 0, put x is equal to 0 and y is equal to what? Sorry, not x is equal to 0, put y is equal to 0 and x is equal to z. Here you can see the approximation I am having what? The approximation, put x is equal to z and y is equal to 0. All these things are related, or all these things in the form of the z. With the integration, you can have f dash z is nothing but what? Fz. So this is what the formation of analytic function with the help of what? Milne-Thomson method. So I am repeating the last thing. First, if you are having the real part and it is asked to evaluate the imaginary part, directly apply CR equation. And if you are having the real or imaginary part and you are asked to evaluate the function, that is the analytic function, you can apply the Milne-Thomson method. Okay, so let us have the questions from the booklet. We'll have the question from the booklet, and between the questions we'll have some more concepts and we'll get some more concepts by solving the questions, dear students. So you can start the question directly, because in this we'll have the basics of CR equation and that's it. No other big formula here. So you can directly, without revision you can go, because we'll have, yes, in the question we'll again write in this kind of equations to have the, what we can say, to have the concept. But yes, in next video I am not going directly to the workbook question. I will have some examples for the analytic function, or to check the analytic function, or for Milne-Thomson method, and after that video we will start the our booklet questions. Here I am having some examples of analytic function. So let us have some examples. So examples are related with the analytic function, right? I am having 1 or 2 or 3 examples. Let us have number 1. Okay, fz is equal to z raised to power 3. We need to check the functions, we need to check the functions analytic or not. Fine, the functions are analytic or not, we need to check this. Number 2 is fz is equal to, it is nothing but our pure sine z. Number 3 is fz is equal to mod of z into z. What we are saying, what the modulus value and the complex number. So these 3 functions, let us have from very number 1 function. So I am having number 1, first number I am having z raised to power 3 here. So let us check whether it is analytic or not. So number 1 is nothing but fz is equal to z raised to power 3. So for the analytic function we need to check the CR equation, and for CR equation we need to have what? We need to have what? The real and imaginary part, right? So z raised to power 3 is what? X plus iy whole to the power 3. So let us have the cubic equation here. So I am having a cube plus b cube plus 3a square b. So I am having a square b plus 3a b square. Okay, so here we are having the separations. So I am having u plus iv is nothing but x cube is a real part, fine, and this is the square term is also the real part. So I am having minus 3xy square. So this is nothing but the real part plus I. What I am having imaginary part is nothing but I is common. So I am having 3x square y. So this is what 3x square y, and I power 3 is minus I. So I am having minus y power 3 because I is common, fine. So this is the value, this is nothing but u, and this is what? Our v, fine. So for analytic function we need to check the CR equation. So what are the CR equation? I am writing here del u by del x. Firstly we need to calculate the value of del u by del x. So differentiation with respect to x, I am having 3x square minus 3y square. Now del u by del y I am having here. So what is the del u by del y? Differentiation with respect to y is 0. So this is what I am having here, 6xy. Now we have the differentiation of real part with the respect of x and y. Now I am having the differentiation of the imaginary part. So del v by del x is nothing but del v by del x is nothing but del v by del x, right? So it is nothing but 6xy. So I am having 6xy, and again del v by del y. So it is nothing but 3x square minus 3y square. So you can see this value del u by del x is equal to what? Del v by del y here. So I can write del u by del x, this is equal to del v by del y. So this is the first CR equation which is satisfied. Now again in the second number you can see this is plus 6xy and this is minus 6xy. So I can write like this also, del u by del y is nothing but minus sign of del v by del x, my dear students. So this is I am having what in the second CR equation. So I am having here green signal that this function is what? This is what? It satisfies the CR equation, that means it is analytic function. So already it is what we are having the polynomial function. Polynomial function is by default the entire function, so that is why it is what analytic function. So let us have number 2. I'm having number 2, fz is equal to sin z. So sin z is nothing but sin x plus iy. We have done with the separation, so I'm writing here u plus iv is nothing but sin a cos b, right? So sin x into cos iy is nothing but cos hyperbolic y plus I sin x, and here we are having sin hyperbolic y. Fine. So you are having the real part is nothing but u is equal to sin x into cos hyperbolic y, and the imaginary part is nothing but what? Cos x into sin hyperbolic y. So let us have the value, my dear students. Here you can have the value like this, del u by del x. So del u by del x is nothing but what? Sin x, the differentiation of sin x is cos x. So cos x into the differentiation, so here y's term is constant, so I am having cos hyperbolic y, again the differentiation with respect to y, so I am having del u by del y, so the sin x is constant, so here I am having the constant, and the differentiation of cos hyperbolic, any hyperbolic function, the cos hyperbolic's differentiation is nothing but plus sin hyperbolic y. So this is what we are having the differentiation. Now the differentiation of v, so I am having the differentiation del v by del x, and also here del v by del y. So firstly del v by del x is nothing but with respect to x, so I am having minus sin x and sin hyperbolic y, and del v by del y is nothing but cos x, and the differentiation of sin hyperbolic y is what? Minus cos hyperbolic y? No, it is cos hyperbolic y. So yes, it is cos hyperbolic y. Fine. So here you can see del u by del x is nothing but equal to del v by del y, and also del v by del x is nothing but minus sin of del u by del y. So yes, we can see here del u by del x, that's the satisfaction, right? Del u by del x is nothing but del v by del y, yes, correct. And again del u by del y is nothing but minus sin of del v by del x. So here in the number 2 I am again giving you the green signal that it is the analytic function. So let us have number 3, my dear students. Here I am having number 3, and here number 3 I am having fz is equal to mod z into z. So what is the value of mod z? Is nothing but x square plus y square root value, and z is nothing but x plus iy, dear students. Fine. So here let us multiply and have the, what we can say, the real and imaginary part. So I am having the real and imaginary part like this. I am having u plus iv. So the real part is nothing but x into root over x square plus y square plus I y and root over x square plus y square. Fine. So this is what we are having here, the real part, and here it is the imaginary part. Fine. So for real and imaginary part we need to differentiate to check the Cauchy-Riemann equation. I am having u is equal to x root over x square plus y square, and this is what we are having here, v is nothing but y and root over x square plus y square. So let us have del u by del x. So del u by del x is nothing but, okay, here you can have the first function and second function's differentiation. So it is nothing but the product rule. I am having first function, and the differentiation of second function is nothing but 2 root over x square, because it is under root term, so root over x square plus y square, and also the differentiation of x square is nothing but 2x plus. See, what I am having is first function, right? First function with respect to x, I am having first function, and differentiation of this. So differentiation of this is nothing but what? The differentiation of this is nothing but 1 upon 2 root x, and for this value this, and the second function is nothing but x square plus y square, and yes, the differentiation of first is 1. Now here you can see this is what we are having, 2 and 2 cancel out. What I am having is exactly x square upon root over, see this value, x square upon root over x square plus y square, and plus under root x square plus y square. So let us we need to check, right? If it satisfies CR equation, then del u by del x must be equal to del v by del y. So, I am having the differentiation with respect to y firstly, because here you can see it is y and here you can see it is x in the form of x. So, most probably it is not like, it is not means it is the, what we can say, I am seeming that it is not equal, but let us check. So, I am having again first function and the second function. So, first function, the differentiation of second with respect to y, and I am having 2x square plus y square, and the differentiation, dear students, I am having what with respect to y is 2y, plus the second function is x square plus y square, and the differentiation of y is 1. So, we are having what, y square upon x square plus y square, and here you can see plus root over x square plus y square. So, this two value is not equal, this two value is not equal. So, if this two value is not equal, then del u by del x, here you can see the del u by del x should not be equal to, or it is not equal to del v by del y, dear students. So, it is the first CR equation, and this it is not satisfied. So, we cannot give the green signal for the analytic function. So, I am having the red signal that it is not the analytic function. So, it is not the analytic function. So, in our three examples of analytic function, the first two satisfies the CR equation, that is why it is the analytic function. But yes, the last one, the third one, this value, in this we have del u by del x is not equal to del v by del y. This is the very first equation of CR equation, which is not satisfied with this example. So, I am having what, this example is not the analytic function. So, starting to our analytic function, and the third one is not analytic function. So, now we are able to have to solve the questions of workbook. So, let us start the question of workbook with the question related with the analytic function.